Hello, my name's Sarah Martin-Law and I work for BOC. You may not have heard of BOC, but the gases we produce go into hundreds of products we come across every day.
My name is Keith Nicholson and I also work for BOC in the Technical Sales Department. I'm based here at Tame in the Food Technology Centre. BOC supplies hundreds of gases, mixtures and pure to our customers, but in the main we supply air gases, oxygen and nitrogen, which are extracted from the atmosphere.
Whether it's frozen food, fizzy drinks, hospital oxygen supplies, hydrogen power cars, MRI scanners or party balloons, all of them use gases produced by BOC. In order to turn the air in the atmosphere into useful gases to package products, a series of processes must take place. This starts with the air being filtered to remove contaminants such as dust, as these would damage equipment in the plant. The pressure of the air is increased to 5.5 times atmospheric pressure by a machine called a compressor. This process causes the air to warm up to about 75 degrees centigrade. So the filtered and compressed air is cooled down to 6 degrees centigrade by passing through a heat exchanger, similar to a radiator with cold water. As the air cools down, a lot of the water vapour in the air condenses and the free water is drained off.
It is important to remove any remaining water vapour before the air is cooled any further. This is because it will freeze and the ice crystals may block the pipes in the equipment, particularly the heat exchangers. Carbon dioxide freezes at minus 56.6 degrees centigrade, so it must be removed as well because the air will eventually be cooled to around minus 200 degrees centigrade.
A heat exchanger is used to cool the clean, dry air further. Cold gases at minus 175 degrees centigrade are led off the distillation column and into tubes at the bottom of the heat exchanger. The air passes in the opposite direction and heat from it moves into the cold gases. The air cools down to about minus 170 degrees centigrade before it leaves the bottom of the heat exchanger, while the cold gases warm up to about 13 degrees centigrade. In this way, the air is made very cold.
Individual liquids can be separated from a mixture of liquids through fractional distillation. Fractional distillation relies on each fraction having a different boiling point, and it works best if a long distillation column is used. Nitrogen boils at minus 196 degrees centigrade. Oxygen boils at minus 183 degrees centigrade. So we use two distillation columns to separate these elements from the air.
The first distillation column is a high pressure column where pure nitrogen is obtained. When liquefied air is passed into the bottom, the liquid nitrogen in it boils and rises up the column as a gas. The oxygen remains below its boiling point, so it falls as a liquid to the bottom of the column. Notice that there are several layers of trays inside the column. These let the rising gaseous nitrogen come into contact with the falling liquid oxygen, which improves the separation of the two elements. The nitrogen is drawn off at the top of the column and condenses to form liquid nitrogen.
The second distillation column is a low pressure column. It allows any nitrogen that might remain in the oxygen-rich liquid from the bottom of the first column to be removed. This leaves almost pure liquid oxygen at the bottom of the column. The boiling points of oxygen and argon are very close. This makes them very difficult to separate, so therefore we use a third column to remove the argon from the oxygen stream.
The gases separated in the air separation unit can be distributed in small quantities in pressurised steel cylinders. Much larger quantities of gases are distributed in vacuum-insulated bulk tankers as liquids. These tankers travel across the country to food production factories, making the kinds of frozen foods we buy in our supermarkets and store in our freezers at home.
I started my career as an apprentice in electrical engineering and spent a number of years in the energy sector before joining BOC. In my time with BOC, I've been able to gain technical qualifications in parallel with my career development.